Great, thanks for the introduction. You are able to see my screen now, right?
Yes.
Wonderful. So yeah, great to be back again with this community. I always look forward to the Allotrope Connect, though this time it's a virtual Connect. I like to browse through the list of participants, and it's great to see so many former colleagues and friends. So it's great to give you this update here on Zontal and where we stand right now. And I think this title is really what I want to focus on, bringing Allotrope to the people. Because we have had all these presentations in the past of our projects within Bayer, the projects at Brigham Young University, where we're more or less still in a development phase. But now it's really the time where we can announce this first enterprise class platform, where Zontal Space is mature enough through the entire GXP validation process and is just ready for enterprise usage for complete ingestion, conversion, and management of allotrope files. So before I dive into the updates on what we have done, let me just run you for a moment about our company motivation and the reason why we are there, talk to you about the pain points that we are addressing, and then into the technology that we developed in order to solve these issues. I will also be risk affine and try to do a live demonstration, so hold on tight, it will be fun. So the first thing I want to like to point out is that Zontal Space really has the goal of turning data into corporate assets. And within the Allotrope framework, we're all about making data standardized, harmonized, ready for reuse. And at the core of Zontal Space, we really use Allotrope in order to deliver on this promise, so that at any point in time, data produced will become available for reuse, and it's always completely secure, and we can guarantee data integrity. So that is, of course, not something trivial in our industry, because there are these problems that we have. One of the really big problems that we have in current IT infrastructure is this application-centric storage and management of data. We have so many siloed applications that are creating data in their own little world, and that is so hard to break into and to share across other applications. And with the greater and greater pressure on digital transformation and getting us in a position where data truly becomes an asset, we want to be able to get this data in a state where it can be reused. If we look at the current constraints, though, estimates are about 80% of data are not usable again in the future because they're either lacking quality, there's a lack of descriptive information, we lost the context, the process that designed the data, and so millions are spent every year just on duplicating data that theoretically is available, but we cannot leverage yet. And of course, within Allotrope, we are aware that data standards are just one thing that's really lacking. The plethora of available data formats just makes it impossible to come up with a single out-of-the-box solution that just can browse for whatever is stored on all of these SharePoints, file drives, data management systems, and whatnot, what we can find. So we want to be able to go into a place, into a world where data is no longer living in the wild, wild west, but where it is governed and structured so that we can ensure that compliance and data integrity are there through data standards that allow us to reuse. And I think the only way to get there is by getting away from the idea of application-centric data and becoming completely data-centric and process-centric in the way we structure and harmonize our data. And for this, of course, we're grateful for our community. Most of you are affiliated right now with one of the companies shown on this slide. Some of you might be new to the Allotrope Foundation and hear your first talks here. I just like to point out that the efforts that have been done here over the last, 6-7 years, they're really tremendous. And the results of it are really bringing forward a technology that is truly enabling. What we can do now is we can leverage the Allotrope data format to truly take simple data files that are produced somewhere and enrich them. We can lift them to a higher level. We can make them truly findable, accessible, interoperable, and reusable by leveraging all the ontologies we've defined, by leveraging the data models that are under development that have been developed. And so because the format is now ready for this, we have built the Zontal Space platform really around the Allotrope data format. And while it is at the very center of Zontal Space, it is not necessarily something that an end user has to worry about, because what I consider Allotrope is really an enabling technology that should never be some type of high energy barrier that we have to force people to jump over to learn and to use. It should really be just like a PDF that on a click, I can get the information out and I have not to worry about the UTF-8 encoding or whatever sits behind it. I can just use it in order to get maximum business value out of it. And that's always been the idea behind Zontal. And in this, what we coined the first fair digital integration platform, we really have tried to bring all of these business benefits together by saying that it's now possible to take the Zontal Space platform and to connect and integrate all types of data and lab applications. So to completely automatize the process of taking data from its native state and go through the enrichment process of semantically enriching it, of converting it into the long-term stable and harmonized data format, and to then make it available to anyone that might want to get some business benefits out of it. And by driving this digital transformation, we can really connect all of these data producers to the data end users, and leveraging Allotrope at the core of this as the enabling technology that makes this an all more seamless and long-term stable. The holy grail, of course, is always that we want to get our data to the point where it will transform a business, where it will get our customers into the position to do things that are currently impossible. And when we think about what our data scientists are currently spending their time on, being able to make all of these wonderful data sets that are sitting around somewhere in silos available for machine learning and artificial intelligence. That is really going to be the main business differentiator that can get us into the next level of drug discovery, manufacturing, producing, and also collaboration with the suppliers and CMOs and CROs. And while a lot of ideas around the data digital transformation have been discussed in a variety of industries, one of the specific challenges that we face within the life sciences is always the strong regulatory component. And so Zontal Space, having been developed together with the Allotrope Foundation and with pharmaceutical customers, really can deliver to the specific market, as we have the ability to go through the full GXP validation process, as we can guarantee full data integrity and compliance. And so this is more or less the overview of what we coined as first fair digital integration platform. Here's one slide that goes a little bit more into detail, but what I really want to point out here is that in the past, we have been used to hear so many different buzzwords like data lakes, data hubs, data preservation tools, data archiving infrastructure. All of these words, they don't necessarily mean something to the end user. What the end user cares about is basic functionality, about things that make their life easier and enable them to do things that were previously impossible. And so what Zontal Space wants to do is to take away all the mysteries of these different things and just deliver the business benefit to the end customer by saying with Zontal Space, it is possible to guide the data through the entire life cycle, which means after data is created, we're able to ingest it, we're able to enrich it with metadata, we're able to enrich it with process information so that it becomes truly information that can then be stored, long-term preserved, and made accessible for future reuse. And by being able to cover this entire life cycle, we're really able to deliver something to the customers that is currently very difficult to achieve with the application-centric designs. But since lots of you have seen this and other slides in the past, let me now focus on what is new in Zontal Space. And really great new use are the Allotrope conversion services that we have now implemented in our solution, which enable rapid testing of data models, conversion of raw data, and then reuse of instrument data that is stored within Zontal Space. So what you can see here on the left side is what we all deal with, raw data. It comes in a variety of formats. Here, 3 examples are given. You know we have way too many of those. Raw data sits everywhere. What we have been doing within the Allotrope context is we have learned how to build data models that somehow give us a logical mapping between the information that is in this raw data and the ontologies that have been built. But who at this point is actually able to take raw data and a data model and build a meaningful ADF out of this? The construction of allotrope data files has has proved to be an unnecessarily high energy barrier. Allotrope, by design, is supposed to be an enabling technology and not something that slows you down on your path forward. So after you've built a data model and you have your raw data, it should be easy to just go ahead and create an allotrope file. And because it wasn't easy, Zontal went ahead and built a conversion service that now makes this easy. So right now within the Zontal Space platform, we're able to load in a data model, raw data, and build out of it allotrope files, which I will demonstrate to you. And what's even more, when we think about the end users of data that really do not care about what format it is stored in, like our data scientists or normal scientists or someone that wants to respond to an audit, we have to make it possible for those people to access the information inside of an allotrope file seamlessly so that they don't have to learn some weird API calls or have to decode some binary files, anything like that. It should be easy for them to do what their job is, to generate business value, to do analysis, to compare data sets, to prove data integrity to some external reviewer. And Zontal Space now provides a user interface and an API that makes this very easy for those customer groups, which I'm going to show you in a second. So now it's the scary part of this presentation, live demonstration. So what I want to show you is I have here some demo data, which you may not be familiar with, bioreactor data, where we have measurements created that show us, for example, how many cells we have in one of these bioreactors, what their viability was, what their total density is, and some other metadata values. So this is a common measurement that comes out of one of these systems. And we are now interested in taking this plain JSON file and converting it into something that is a more meaningful representation because it has information about the context, it has information about how and when and where it was taken, and it's long-term accessible, and it becomes all of a sudden comparable to other data sets and integratable. Okay, so that's what we want to do. We want to transform this guy into an allotrope file. How do we get there? Well, we need to have a data model, right? We need to be able to map these keys against something in our ontologies. And that is now no rocket science anymore for people within this foundation. So we're able to define tags, and we can define, for example, the mapping between ontology entries and the keys inside of the data set. So if we develop such a data model, we would now like to find out, can we combine the data model and the raw data into a meaningful ADF? And like I said, the Allotrope conversion service on the space is supposed to exactly make this task easy. If I look in here, I also have other renditions of the same raw data. So I have an Excel file here, which when I open it, that's the beauty about Excel, it always takes so long. I have a data table that contains exactly the same metadata, and I have also a PDF rendition on my other screen right here, which contains the same information as well. So 3 different data forms with the same information, whatever is delivered by your instrument. Now I'm going to show you how we're going to convert this within the Zontal Space network. So here's, let me refresh this once, as it typically logs out. Here's our Zontal Space login. This is the search interface, kind of Google-like, which is neat. But what we're doing right now is we're doing a conversion. So we want to ingest some data into Zontal Space. So for this, I can click here and I can select new files. For example, I can take my JSON file and let's this raw data JSON file and the cell counting model, and I upload those maybe as a JSON upload test. I can select an information package profile that defines the metadata. After selecting this, now in the background, this data set is being moved from my basement in Utah to our server in Germany. While it does this, there it is. It creates now this file. And as you can see, currently it's trying to run through the ingest. So here's some exclamation points that indicate that metadata has not yet been identified that we defined before to be mandatory. And so it didn't propagate, but after the scripts worked, now it's been ingested. So if I go into my Explore screen, I'm able to see here the JSON upload test that we just uploaded. And here in the interface, I can see the metadata that was extracted in a UI, easy to read fashion, for example, the total cell density. If I investigate this and I open the context, I can see that both JSON files are correctly loaded in here. We could have done the very same thing also for the data model in combination with a PDF file. Or can do it in parallel also for the Excel file. That's the beauty of the Zontal space system. We make it easy to work with different file formats and just take the energy barrier away of going from those files into the Allotrope format. So uploading this as well. And if I go on the Explore, we should probably see up the PDF. It's been also submitted. We can see the metadata being extracted. It's more or less the same information as in the JSON file. You can see the contents. Now we have the PDF and the JSON file in here. So is this an ADF file or is it just something that looks like it in my interface here? I can show you by downloading the ADF archive. So here my PDF upload test has been downloaded with a .adf file ending. That's already a good sign. So if I go into ADF Explorer, I can open this guy. And I can see here that I do have a data description, a data package. Wait, which one is it? The PDF upload test, this one, right? So I have a data description, a data package, and an audit trail. So if I go into the data description and open this tab up, I can see here now that, for example, down here, the viable cell density has been correctly mapped in RDF against the subject, predicate, and object. And so I can find the complete RDF representation of the metadata here to show you that we actually really created a meaningful allotrope file that does have a data package in which the raw data sits, the cell counting PDF, and then a JSON rendition of the PDF file, if for some reason you prefer that. Also nicely to be seen is the new feature of the audit trail of the allotrope file. If I click in here, I can click through it, and I can see that the Zontal space system meticulously tracked every single event that happened to the file. The file has only been, how old? Like 2 minutes, but it's already 6, 7 different entries inside of the audit trail that really track every single thing that happens to your file since its creation. So if you imagine that you have a direct connection between your instrument data and Zontal space, after the data has been created, every single thing that happens to your data set is going to be tracked within the system, which is great for data integrity and future audits. And speaking about audits, we said we want to make data inside of an allotrope file easily accessible. So one thing that Zontal does now as well is it creates automatically a word rendition of the information, so that it is easy for someone without the technical background to go in and read the information and report it to someone that might ask some questions about it. So those are all nice features that show us that the conversion from raw data into allotrope works well. But you might say, hey, that's nice. You have this UI and the uploads, they seem to work when you do it manually, but I'm someone that creates terabytes of data and I don't want to do this manually. And I can sympathize with you. So what we might want to do is look at a different type of data set. Let me open it up here. Let's Look at this one. Here I have 1,000 different data sets that come out of cell counters. I still have one model that models it, but I have now for an anonymized company created a bunch of sample data drawn from standard normal distributions, but different values. So simulating the idea of having a constant stream of JSON files that pop out of a system. And maybe you already have them stored somewhere and you would like to ingest them. So how would you do a bulk ingest within Zontal Space? Well, one thing you could do is you can use Jupyter bindings that we have to define a basic upload function. So here I've defined a basic upload function within Jupyter that is able to upload JSON files. And this is really just a collection of standard Python bindings to web UIs. There's nothing fancy going on here. And the second function that just allows us to add multiple JSON files if we want so to an upload. Okay, the actual work of ingesting bulk data is done here. All you need to do is specify where your data sits, specify the data model that you want to use, select your data, and then upload it. So if I kick this off, I will see that takes a moment, but then I've uploaded my first model. So I'm going right now from random model 600 to 700. And as they're being uploaded here, I can go into the web UI and I can see here they're being created. Similar to before, they're currently in the queue for being converted into Allotrope files. This takes a moment, but the conversion, I think the conversion for the first files happened. So I can go in the Explore screen and I can see that these files are now here. And if I toggle through them, you can see here that the metadata indeed changes. So those are different information packages that are being created, different Allotrope files, and they contain the metadata or the raw data as measured in the JSON files. So I guess for this demonstration, I don't have to go further. I can stop this. But what this has shown you is it is quite straightforward to do a bulk ingest of a large number of files. And so you can really streamline the generation of Allotrope files through the Allotrope conversion services within Zontal Space. The other thing I told you about is what's going on with the data scientist and the scientist that just wants to access data. So let us first talk about the use case of the data scientist, into which group I consider myself to belong to as well. So I think the job of a data scientist is to do things like this here. It's defining functions in any type of language, R, Python, whatever it might be, in order to create business insights. So what I did here is just define some basic plotting function that should be able to give me meaningful representations of data within these JSON files. Now, this is something a data scientist likes to do and wants to do. Unfortunately, what is shown in this cell is what data scientists spend 80% of their time on. And that is getting access to data with which they can do fun stuff that is helpful to your business. So here, instead of spending 80% of my time, I spent like 3 minutes to write a basic request call that goes into our Zontal Space web API and downloads all the archived information packages, downloads the metadata from it so that I can pass it into my plotting function. So when I execute this, it's now connecting to the Zontal Space web server. So it just happened live. It downloaded all the data and then it made some plots. So here, for example, it showed me the total cell counters per sample that's in the system, the total viable cell counters, and the average life cell diameter. And as these are not very helpful representations, I also made histograms of it. And what I can see is that my randomized data is nicely randomized, following these Gaussian fits. Just doesn't really work for viable cell counts, as it's pretty right-handed, by 0 being the boundary here. But that is something you might want to do as a data scientist. And after you've verified that your data is read correctly, you might want to do some science and ask yourself the question, for example, is there some type of correlation between my average life cell diameter and the viable cell counter? And in this case, I don't see any, since they're both independent random distributions. But those are the type of questions you want to answer, and you want to be able to do this quickly as a data scientist. So with data being stored within Zontal Space, it really just single API call, and then you can build up your dashboards the way you like. so that you can get this information as you need it. So not everyone feels comfortable looking at code like this, and therefore we also provide some alternative ways of dealing with data inside of ADF files. And so what we developed, for example, is an SQL interface that allows your scientists now to browse an ADF like a file browser. So you can just open it up and look at what's inside of it. Another thing we have done is we have built Spotfire integrations so that without the need of big coding efforts, you're able to rapidly create your custom dashboards based on Allotrope files. And using processes like this really allows you to run analytics across batches and processes. You can compare different systems, different locations, really gain some insights on how your processes work and what comes out of it at the end of the day. So this can help you really drive meaningful business decisions and help you optimize your workflows. So with all of these features being in place, it's quite fun to go through the conversation of what customers need and what they want. And as I said at the beginning, we want to bring Allotrope to the people. And that also means that we want to work together with people. And therefore, we consider ourselves really as team players. And I'm really excited to announce some new partnerships that Zontal has formed throughout the last 6 months and some future opportunities for everyone in the community. So first, I'd like to point out our collaborations together with Agilent. Our integration partnership really helps people to bring forward the close integration of instrument data and long-term data storage or data preservation. Then our collaboration with Accenture, where we are teaming up in order to really drive forward digital transformation on the enterprise scale. Through the Accenture consulting, through the Zontal Space solution, we're really able to offer a holistic package that can transform a complete enterprise. And then thanks again to Bax for his nice presentation before me, we also have the solution partnership with Zifo that allows us to really expand the number of use cases for which Allotrope conversion can become a reality for our customers. And now for lots of you, maybe a very important announcement. As it has been proven to be hard to generate Allotrope files, we want to make this service available for the entire community. And so I'm very happy to announce that the Zontal Space Allotrope conversion service is now available to all Allotrope members and Allotrope Partner Network members for their converter development. So we are going to host a Zontal Space instance, and you will be able to leverage these APIs and these presented features to convert your data and data models into Allotrope files. So with this being said, we are still looking forward. There's a lot more to do. And if you can identify other win-win situations, I'm very excited to talk to you. So please contact me. My email is shown here. And thank you very much for your attention.
Great, thanks, Dennis. It looks like we will have time for probably one question here as well. Just a reminder that if you want to ask questions, you can use the raise your hand function, or you can also type in a question into the chat, and Jamie will get that as the organizer. Jamie, do we have any queued up?
Yeah, there's actually two short ones, I think. One is the ADF disassembled when it's stored in Zontal Space?
Nope, it's a full ADF file. It's not disassembled.
All right, and then the second short one is the Spotfire integration based on TIBCO data virtualization?
I'm not the expert on that integration, so we would have to refer to Wolfgang to it. So if that person wants to send me an email, I'll give him details.
Great. Any other questions?
That looks like that's it.
All right, we'll keep moving then. So thank you, Dennis.